periodic table. Elements are arranged in the periodic table. This is where the whole elements are arranged, and it was developed by a scientist called Dmitry Mendeleev. He's a Russian chemist. He developed the periodic table that contain all the 118 known elements. All of them are arranged in a place called the periodic table. This periodic table is classified into two, but every element that you see in the periodic table has a peculiar characteristics. You don't just go around and pick any element and put in the periodic table. There is what we call periodic law. Periodic law states that the properties of elements are the periodic function of the atomic number. That is to say that atomic number of every element plays a major role in determining its chemical properties. So periodic table, according to the scientists that developed it, is classified into two. You have groups and you now have what? Periods. Groups and periods. And of which the group is located in the vertical section, vertical column, while the period now you see them in the horizontal row. Horizontal row. Period in the vertical, all of us know what vertical is. Vertical is like this. Now, when we are talking about horizontal, we are talking about things like this. So, group in the periodic table is the vertical column, while period is the horizontal row. So, we have 8 groups and now 7 periods. Don't forget that elements are arranged in the periodic table according to their atomic number. So we have 8 groups and now 7 periods. That is to say that we have group one. We have group one element, group two element, group three, group four, five, six, seven, up to zero. Group zero or group eight was elements. And we have 7 periods. We are going to look at the characteristics of elements in the same group. Just take a look of the periodic table, how it is. You see, every element is there. You see groups and you see period. Just like this one, you have group one. You have group one, you have group two, three, and all the rest of them. So every element are arranged there. Now, every element in the same group have a peculiar characteristics. Elements in the same group have the same number of valence electrons. Elements in the same group, they have the same number of valence electrons. So elements in the same group now, they have the same number of valence electron. And what is valence electron? Valence electron is the total number of electrons on the outermost shell of an atom. Total number of electrons on the outermost shell of an atom. You remember electronic configuration using KLON. Using KLON. Just for instance, sodium is 11. If you are asked to write the electronic configuration of sodium using KLON or in the main shell of an atom, so I think the summary is supposed to be 2, 8, and 1. Or you can still draw it the normal way you know how to do it. The first shell will take 2 electrons. All other shells now will now take 8 electrons. So this is sodium. This is now 10, and this is 11. So if you count this thing now, it's 11 electrons. If you watch the outermost shell, is this one. How many do you see there? Is it only 1 electron? That is to say that sodium is qualified to be placed in group 1 because it has 1 valence electron. That is, it has a total number of 1 electron on the outermost shell of the atom. So every element in the periodic table has a peculiar feature which qualifies it to stay there. Elements of group 1, all of them will have one valence electron. Let us see three examples of elements of group 1. Four examples of elements of group 1 are hydrogen, lithium, sodium, and the potassium. This is the element of group 1. Hydrogen, lithium, sodium, and potassium, at least up to period 4. These are the examples. Let us see if actually they will have one valence electron. Hydrogen is just 1. Lithium is 2 and 1. Remember, K shell will have 2 electrons, and other shell will have 8. Sodium 2, 8, 1. Potassium 2, 8, 8, 1. I believe you understand this. This is electronic configuration of elements using KLOM or in the main shell of an atom. This is the first shell, K, this is the second shell, this is the third shell, this is the fourth shell. If you watch all of them, their outermost electron have one electrons each. That is to say that they are qualified to be placed in group 1. Another example, elements of group 2 will have two valence electrons each. Elements of group 3 will have three valence electrons each. What are we trying to say? Elements in the same group will have the same number of valence electrons. And I have explained what valence electron is. Total number of electrons on the outermost shell of an atom. The outermost shell, the last shell of every atom, count the number of electrons there. Any number you see there, that is where they should be placed in the periodic table. That is it. On the board are examples of group 2 elements. That is beryllium, magnesium, and the calcium. Group 2 elements. Let us see whether they will have two electrons each on the outermost shell. Beryllium is 4, 2, 2. Magnesium is 12, 2, 8, 2. Calcium is 20, 2, 8, 8, and what? 2. If you watch, their last shell all have two electrons each. Let us consider element of group 7. Group 7, which are called the halogen. They are fluorine, 9, chlorine, 17. So let us consider these two and see whether they will have seven electrons each because they are in group 7. 2, 7. 2, 8, 7. If you watch, their last shell all have seven electrons each. If you still want another one, let us consider elements of group 4, like carbon. Carbon is 6. Silicon should be in group 4. Let us see now. Carbon 2, 4. Silicon 2, 8, 4. So they have four valence electrons each. So they are qualified to be placed in group 4. This is how this man fashioned the periodic table. He don't just pick any element anywhere he sees and post it there. They have peculiar characteristics. Just like we have seen that elements that belong to the same group, they must have the same number of valence electrons. We are going to consider the property of elements in the same period. Watch.